All right, guys. So real quickly, do now. 1/2 times 3/4. Anthony.
8/12.
8/12. Where'd you get? Hold on, hands down. Where'd you get 8/12?
Because you have to multiply them across. Then I got 4/6 and then I simplify.
4/6. Simplified to 8/12. Did you multiply or did you add? You sure? Well, hold on.
4 times 1 is 4.
Oh, you cross multiplied, right? That was when we're doing proportions. But remember, when there's a multiply sign in there, we just multiply straight across. So 1 times 3 is 3, and 2 times 4 is 8. Does that simplify? Does it simplify?
Oh, no.
No, right? Doesn't simplify. Good. So that is simplified. 2/5 and 1/4. Jake. 2/20. Does that simplify? Does that simplify? Give it away. Yeah, right. It becomes 1/10, right? Because they both divided using UG. All right. So today, this kind of goes what we're gonna talk about today. We're gonna be multiplying some fractions, but we're gonna talk about probability, right? So we've already talked about probability. We talked about 2 kinds of probability, right? Talked about theoretical, and what was the other kind we talked about? There were 2 kinds.
Theoretical and
It starts with E.
equality.
Don't call out, please.
Experiment.
Experimental. Those were 2 different kinds of probability. What's the difference? I mean, what are they? Raise your hand and tell me. Curry.
Okay.
Tell which one you want to tell me about. Theoretical or experimental?
Experimental. Okay, experimental is like you experiment. You do like a number problem to see how it comes out, and you like guess like what's the probability gonna be.
Okay. Right. So theoretical. Right. So theoretical talks about what should happen. Right. So based on what we have, what should happen? If I flip a coin, right, I should get heads and tails. Like, I should get heads 50% of the time, tails 50% of the time, because that's the odds, right? That's what we have. That's what should happen. And what was experimental? There.
Experimental was if you test out the project that you're doing.
Right. So if you do it, what do you actually get, right? And are those always the same?
No.
They're not. What happens if we do the experiment 5 times? Are we going to be as close to the experimental? If we did the experiment 5 times, are we going to be as close to the theoretical probability as if we did it 500 times?
No.
No. The more we do, right, the closer we get, right? So today we're going to talk about some more probability. You know I like probability. So we're going to talk about dependent and independent events, okay? So Jalen, you are a pretty independent guy, right? You'd say that? What does that mean?
Don't really hang out with people.
I mean, you can
Well,
hang
I
out.
do hang out with people,
But what?
I follow my own rules.
Yeah, kind of, yeah, okay, yeah. You do things kind of on your own, right? You don't necessarily go with the crowd, right? You're your own guy, right? What do you think? What do you think about independent, Anthony?
What? What's the question?
Independent, what does independent mean?
It means that you're your own person. You don't follow behind anybody else.
Yay.
You go your own way.
So you make your own choices, right? So you don't make choices like, I don't say, all right, Jay decided to wear a Pistons jersey today, so I'm going to wear a Pistons jersey, right? So you say, I don't care what anyone else is going to wear. I'm going to wear OU, right? This is a better school than any place in Michigan. So when we talk about independent events and probability, okay, when we talk about independent events, what do you think I mean by an independent event? What do you think I mean by independent event? Something that happens on its own. Okay, that's great. Something that happens on its own. Yeah?
Something that doesn't have any rules. It just happens.
Doesn't have that many rules, maybe, just happens. Okay. No, these are really great. You're using what you know about words, right? You think about math. Okay. What about, so when we talk about probability, right? There's usually like we pick something, we flip something, right? And we can come up with like probability for that, right? We usually use fractions, like out of this many choices, right? So independent. Okay, so we'll go back to that. What does dependent mean then? Just the word dependent, not dependent.
And it means like you rely on somebody else.
Means what? You rely on somebody else? I thought you said you lie on somebody else. I was like, that's not nice.
You know somebody to
Right.
give you something?
Right.
For a job or-
Yep. So maybe you make choices, people. So maybe instead you said, oh, Jay Walker is wearing a Pistons jersey. I am wearing a Pistons jersey. Right? So my choice was dependent on what he did. Right? Make sense? So let's talk about probability that way. So I have my amazing OU hat because, you know, I love OU. And I have some cubes. Okay? We're going to talk about the probability of choosing some of these cubes. So I write this down so we can keep track of what we got. We got 5 white cubes. Right? We have 5 black. Notice I picked all. And then we have, oh yes, we have red. 9 red. Okay. So we're going to talk about independent events first. Okay. So an independent event is an event that happens and then the odds of something else happening, okay, don't rely on what happened first. So for example, first let's look at what would be the probability of choosing red. So this means probability of choosing red. How many total cubes do I have in my hat? 19. And how many times can I pick red, Desiree? So the probability that I pick a red is what? 9 out of 19. Okay. So let's say, what's the probability of picking a red and a red? But what I'm going to do is I'm going to, after I take one cube out, I'm actually going to put that cube back in. For example, I have this hat, and what's the probability the first time that I'm going to pick a red? 9 out of 19. There are 9 out of 19 chances I'm going to pick a red. So Jay is going to pick a cube for my hat. It doesn't stink, I don't wear it. And he picked a
Red.
yay! Right? Boomer sooner. All right. So we're going to put back the red. Now when we put it back, right? And now I'm going to say, what's the probability that he would pick a red again?
19.
Oh, it is. Because why 19 again, Jay?
Because it's still 9 inside of that. Not 8.
There's still 9 inside the hat. True, there's still 9 red, but there's also still what?
19 cubes.
19 cubes. Okay. So to find the probability of event after event, if they're independent, right, then the probability stays the same because we put it back in. Okay. For a probability to be independent, it can't. The first one doesn't. It doesn't matter what happens in the first one. Okay. We still have the same odds in the second one because we put it back. All right. And so to find the probability of picking 2 reds, then we would multiply these fractions together. We multiply these fractions together. What would we get?
81 over.
I should see some pencils going. 19 and 19, let's go. Who gets it first? Who gets it first?
360.
Are you sure?
Yeah.
You're right. Does it simplify?
Yes. Wait.
No. Alright. 9 doesn't do it. Alright. Good. So that's what independent events are. So if I take something out, as long as I put it back, it's the same. So let's talk about dependent events.